Aerospike has been our part and parcel of our modernization journey, and we'll walk through our goals, objectives, and the details. And we started this modernization in 2014. This was our vision. We want to build better, faster, and cheaper solutions. That is becoming a challenge, and that was a big challenge we want to meet. Also captured what architectural principles we started with. We wanted to have one operational data store having all the data readily available for all applications. We don't want to talk to multiple databases in addressing or handling one request. And we don't want to do any local caching at VM level. All the data needs to be stored in data store, and every application should access it. And also we had maximum code reuse. That was one of our principles. And avoid or minimize cost outside CLR JVM. This is one area where we wanted to move away from the typical multi-service. When a request is received by the server, all the business logic should be handled within that CLR or JVM. So we moved away from that multi-service architecture where there will be an orchestrator calling multiple services. That will add a lot of time, latency, throughput, everywhere it will come. And the last one is AppTire is just business logic, and it should be able to run on lightweight VMs. In this, they're providing a view of where we were in 2014 versus now. In 2014, all the core trading applications were on mainframe. It's a limited skill set. Scaling is costly. Development takes time, and constraints on latency and throughput. Mainframe comes with, it can scale, but there is a limit to how much we can add MIPS and scale. And availability, which is another big DR challenge. Just wanted to provide a quick overview of what the kind of business we are in and why this 2014 view is not acceptable anymore going forward. The trading is the core of what's the backbone of Schwab brokerage. We have, as of today, some 7.7 trillion assets of our clients. And we wanted to offer full brokerage, like all the customers should have access to every type of product that is out there. And they should be able to come through any channel, whether a browser, mobile, iPad, thick client. We want to offer all sorts of channels. That comes with two, and on top of that, particularly for a brokerage application, we are very sensitive to making our applications available during the trading hours. On a typical day, the trading hours are open from 9:30 a.m. to 4 p.m. Eastern time, and that time is very paramount to us. Any outage during that time, we are making our customers lose the opportunity to trade and invest the money in the way they wanted to invest. The market will be swinging drastically, and the customer might lose some dollars. So we are very sensitive to availability. We wanted to have our systems available during that market open time, 100% available. 100, I know 100 is kind of asking too much, 99.99%. And outside that market hours, still there is early market trading, aftermarket trading, and our applications should be available outside that trading hours as well. We wanted to have consistency in our data. So whatever channel customer logs in, they should see one consistent data. There should not be any discrepancy in between channels or between calls made from the same client on the same channel. So that was the challenge we were trying to address 2014, looking back at that point. Coming to here, current view, all the client interfacing applications are now decoupled from mainframe, and DB2 is retained as a system of records for all legacy applications. We are calling this out because only trading is moved away from mainframe, but there are many legacy applications still residing on mainframe. So we want to make sure they get all the data they want. So mainframe retained a system of record for all the legacy applications. And all our development is on .NET platform with Aerospike as our distributed database. We are getting latency into all our applications are handling within 30 milliseconds on average. This is 95 percentile latency, and throughput is 2 million transactions per minute. We are already achieving this. And one last thing I wanted to call out, we deployed in multiple data centers with zone isolation strategy. We'll talk briefly in the coming slides what the zone isolation strategy is. This is one thing we did to ensure high availability. This is the strategy we followed. These are the steps we did at a high level in 2 steps. In the first step, we made Aerospike as intraday system of record. And within this, we migrated all the read applications first, followed by the write apps. What exactly meant by read apps is many times much of our client traffic is about viewing their portfolio, doing various scenarios, what happens when they trade or don't trade, and what are how their margin risk and other things are looking. So majority of the traffic is for read. We read the data from Aerospike and present it to the customer. So for this, we created one Aerospike cluster on the distributed side, and we copied the data from whatever the system of record. And in this case, for most of the applications, the system of record is mainframe. So we copied the data from mainframe into Aerospike, and we try to keep the data near-time updates. So that will involve daily refresh, intraday refresh, weekly refresh as needed. And we deployed the business logic on app type with data in Aerospike. So this is our first step. With this, we are able to migrate over almost 70% of all the customer traffic onto the distributed side. And then we worked on migrating the right apps. So when a transaction happens, when customer makes a trade or buys or sells, sends a cash deposit, there is any such thing, customer is initiating, that translates into updating the database. So in the legacy way, the transaction is posted on DB2, and DB2 will be generating an alert, and we'll be receiving that alert and updating the Aerospike. But in migrating these right apps, we switch the paradigm. We update Aerospike first when a trade happens, and then asynchronously write it to DB2. And for whatever reason, DB2 is not available, that message will remain in the queue, and we'll update DB2 as soon as DB2 comes up. So totally decoupled from mainframe that way. And then the second step, this is a big step, Aerospike as a system of record. When we are building new functionality, new product offering to our clients that require a lot of data need to be stored, now we are not looking at any DB2 or any other database as a system of record. Aerospike will become the system of record. So we store the data in Aerospike when a transaction happens, and we retain the data only in Aerospike and serve it to our customers. In this, I wanted to call out, we have our services deployed across multiple zones in multiple regions, 2 regions across Arizona and Texas. And effectively, we are having 4 zones. But we are not wanted to leverage XDR to keep the data in sync between the zones. This comes with XDR. We leveraged XDR earlier, and XDR works perfectly with very small latency in syncing up the data. But the challenge that comes with is if for whatever reason we promoted a release, the data got corrupted in one zone, all other zones and data centers are already corrupted. So we don't have a place to go during intraday, and restoring is also not easy. So because of that reason, we went with this zone isolation. We'll briefly have a slide on zone isolation coming up. This is the view of current stats with Aerospike. We are having almost about 150 terabytes of data in each zone, and we are on daily basis 75 billion transactions are done on Aerospike. 20 billion are writes and about 55 billion are reads. It's great to see 99.9% of our reads as well as writes are less than 1 millisecond latency. And throughput, what we are seeing is 1.1 millions per second reads and 0.45 million per second writes. This is what we noticed as of today. And at application level, latency, we are able to maintain about 30 milliseconds for all the reads as well as writes. And we are achieving a throughput of 2 million transactions per transaction processing. This is a brief view of what the write applications, read applications. In the first column, these are all legacy applications, mostly mainframe. And in the far right, these are the modern applications we developed on .NET. In the read application, the top three are read applications here. They directly talk to Aerospike, fetch the data, apply the business logic, and either it is fraud management or credit risk management or simple customer-facing services, they'll all be handled. And here, from mainframe, based on the type of application or what application can support, we are fetching the data flat files at the start of the day or weekly refresh, and intraday we are getting those events and updating the Aerospike. We have two types. One is file processor, one is intraday processor. These are the two processors we have built as an integration layer. And they'll keep the data in sync with Aerospike, data in Aerospike in sync with whatever the system of record is. And in the second phase, write applications, they write to Aerospike first and they synchronously write to DB2. And in the third phase, where Aerospike becomes the system of record, any transaction, anything will be written directly to Aerospike, and Aerospike will become system of record. Moving on, this is the zone isolation strategy. So in this, we are making sure every zone gets all the writes into Aerospike so that Aerospike is 100% in sync with other zone. Writes can be coming from S4D files, start of the day files. They'll be written to NAS folder. Every zone will have access to that NAS folder. And if it is, we leveraged Kafka to do the messaging between zones. Any intraday event published onto Kafka, and Kafka will make sure the same event is propagated to multiple zones. We have this multi-node cluster, and there is a drainer on Kafka which will keep draining and updating Aerospike. And also, when customer makes a write transaction, it is real-time written to Aerospike, and a message is published onto Kafka, which will be available for other zones to consume. This way, we are able to achieve our zone isolation and nothing shared architecture. Only Kafka is the one bridging multiple zones. In closing, I want to talk about where we are today. Modernization journey is very rewarding, and we are able to achieve all the objectives that we started with. Aerospike exceeded all our expectations in terms of horizontal scalability, latency, throughput, everywhere. It became a critical component in the ecosystem. We are able to develop an industry-leading performance reporting capability with Aerospike as system of record. This is where none of our competitors have this in-house because of the complexity involved, and offering to every client is a challenge. So long, now we are able to crack that puzzle because of our flexible architecture and Aerospike as our system of record. What's coming next? We are trying to deploy our applications in public cloud and be ready. This is our next journey, which we are working currently on.